am Dr. Anubha Gupta from ABES Engineering College, Ghaziabad. I am presenting video lecture series on electromagnetic theory. In the continuation of this lecture series, this is the part 4 of my lecture. In the previous lecture, I discussed about the Poynting vector and Poynting theorem. In this lecture, topic to be covered, plane electromagnetic wave in free space. As we know that plane electromagnetic waves have some properties in free space. The most important property is that plane electromagnetic wave travels with the speed of light in free space. So first of all, we will understand that what is the meaning of free space or vacuum. Free space or vacuum means which contain neither free charges or nor conduction current. Neither free charges means rho is equal to 0 and the conduction current is 0, means the conductivity of the medium is 0. The permeability of the medium is mu naught and the permittivity of the medium is epsilon naught. Under these conditions, there are general Maxwell's equations which reduces to the following form. There are four Maxwell's equations. First Maxwell equation, which is the Gauss law of electrostatics, is become del dot E is equal to 0. Second Maxwell equation, which is the Gauss law of magnetostatics, reduces as del dot H is equal to 0 because we know that B is equal to mu naught H. And we know that del dot B is equal to 0, but B is equal to mu naught H. So we can write del dot H is equal to 0. Maxwell third equation, which is the Faraday's law, becomes del cross E is equal to mu naught del H by del T. And the third equation, which is the modified Ampere's law, is become del cross H is equal to epsilon naught del E by del T. These are the fourth Maxwell equation. First, second, this one is the second, this is 3 and this is 4. So to find the speed of electromagnetic wave in free space, we will take the curl of equation number 3 or equation number 4. First of all, I will take the curl of equation number 3. Taking the curl of equation number 3, I already know that what is the meaning of curl. Del cross E is equal to minus mu naught del H by del T. This is the equation number 3. And taking the curl on both sides means cross product of del cross E is equal to minus mu naught del by del T del cross H. And this is the vector identity, and we will apply this vector identity. If there is A cross B cross C, there are the three vectors, then it can be written as B AC minus C AB. This vector identity will be applied here. Del dot E minus del square E is equal to minus mu naught del by del T del cross H. Now we will put this del dot E value and del cross H value from the Maxwell fourth equation and Maxwell first equation. We know that the Maxwell first equation is del dot E is equal to 0 and Maxwell fourth equation is del cross H is equal to epsilon naught del E by del T. Maxwell's, if this is the equation number 5, equation number 1 is del dot E is equal to 0. This is the equation number 1. And the equation number 4 is del cross H is equal to epsilon naught del E by del T. This is the equation number 4. Put these values in equation, in equation 5. So equation 5 becomes del dot E is 0. So this is 0 minus del square E is equal to minus mu naught del by del T. In place of del cross H, I will put mu naught del E by del T. Mu naught epsilon naught. It is a epsilon naught. Mu naught epsilon naught. So it becomes 0 minus del square E is equal to minus mu naught epsilon naught del 2E over del T square. This minus sign will be cancelled out. And this equation become del square E is equal to mu naught epsilon naught del 2E over del T square. This is the equation number 6. What is the equation number 6? Del square E is equal to mu naught epsilon naught del 2E over del T square. This is the equation number 6. And this is called the differential equation, second order differential equation for an electromagnetic wave. This represents electromagnetic wave in terms of electric field. And similarly, we know in terms of magnetic field, we know that the equation number 4, from the equation number 4, in terms of vector H, taking curl on both sides, taking curl on both sides of equation 4. Equation 4 was del cross H is equal to epsilon naught del E by del T. And it will be del cross H is equal to epsilon naught del by del T del cross E. And A cross B cross C, again we will apply it. It become del dot H minus del square H is equal to epsilon naught del by del T del cross E. This is the equation number 7. And the value of the del dot H and del cross E can be put from the equation number 2 and 3. It is 0 minus del square H is equal to epsilon naught del by del T. And equation number 3rd is del cross E. This is the equation number 3rd, mu naught del H by del T. So it become mu naught del H by del T. So equation this can be written as del square H is equal to minus mu naught epsilon naught, and it is del 2 H over del T square. This is the equation number 8. This is the equation number 8. So this is the second order differential equation in terms of magnetic vector H. And what are the equation number 6 and 8? In terms of electric field, the electric field equation can be written as del square E is equal to mu naught epsilon naught del 2 E over del T square. And in terms of magnetic vector H, mu naught epsilon naught del 2 H over del T square. The journal wave equation, we know that journal wave equation can be written as del square A is equal to 1 upon V square del 2A over del T square. General wave equation for vector A, for any vector A. So these are the equation number 6, this is the equation number 8, and this is the equation number 9. Compare equation number 6, 8 and 9 on comparing equation number 6 or 8 from equation 9. It gives 1 upon V square is equal to mu naught epsilon naught. And V is equal to 1 upon mu naught epsilon naught, which gives In place of mu naught, value can be put as mu naught is equal to 4 pi into 10 to the power minus 7, and epsilon naught is 8.85 into 10 to the power minus 12. It gives V is equal to 3 into 10 to the power 8 meter per second. It gives the value of V, and which is equal to the velocity of light c. In this way, these equation number 6 and 8 can be written as del square E is equal to 1 upon c square del 2 E over del t square, and this equation in terms of H can be written as 1 by c square del 2 H by del t square. It shows that EM waves travels with speed of light in free space, because by calculating this value V from this mu naught epsilon naught, this is the 3 into 10 is the power 8, and we know that this part shows the velocity which is equal to c. This is the speed of light which is represented as c. So these equations become, these are the equation number 10 and 11. In this way, we have proved that electromagnetic wave travels with the speed of light in free space. These are the references of my lecture. Introduction to Electrodynamics by David J. Griffith, Solid State Physics by S. O. Pillai, and Engineering Physics by S. K. Gupta.